Hello everyone, welcome to my channel. Please look at the disclaimer video RC3 of RC3 channel as I mentioned before. Moving forward, this video talks about RC3 of time where we use the RC3 technique to explore what time is. To start, let's take a simple, high school physics problem where you've got a train A which is going right at 60, train B going left at 40. What time do they meet? Where will they meet? So you say time is 100 kilometers by 60 plus 40, so they meet in an hour and 60 kilometers from here. Right, this is the usual stuff that we do. When I thought of this problem slightly differently, I wanted to conduct it as a scientific experiment. So the first question that we need to answer then is, what is science? I did check with quite a few people. I've talked to scientists, I've talked to a lot of different people and asked them this question, and nobody really seems to have a clear definition of what science is. It does raise questions around how do scientists know that they're being scientific, right? Or how do you know that you're being scientific when you're thinking about something? So there are some interesting questions around that. But moving forward, I came up with a definition of science which I think is reasonably accurate. It covers about 95% of most situations. So the first point is you define what you want to measure. Then you define metrics against each of them. For example, in the above experiment, we want to measure length and time, and we say we measure length in kilometers and we measure time in seconds or in minutes or hours, right? So we define the units, then we conduct the experiment. So we actually make the trains move. We track their distance that they travel. We track the distance between them, measure the time, and so on. Then we measure the metrics. We tabulate the metrics, and then we see what mathematical formula matches the metrics in the tabulation, and that becomes the law of nature, right? So velocity is equal to distance by time, or force is equal to mass into acceleration, etc. So this is the basic scientific process that this is sort of the best definition I could come up with. So question for you guys, what is the scientific approach according to you? Is there a formal definition? Should there be? And what about measureless sciences like psychology and so on, where we do have some elements of hypothesis, logic, causation, etc., that we're applying, but we don't exactly apply mathematics to come up with rules in those cases. So, is this definition, correct? Does it need to be changed, extended? Is it good for 95% of the cases where there's a 5% difference? Do let me know your thoughts. Moving forward. So, coming back to conducting the actual experiment, the problem that we now face is how do we measure time, right? Okay, the trains are moving at certain speeds, but how do we actually calculate the time or the duration that they're moving for? Typically, we'd use a clock or a digital device of some sort, or a stopwatch or a pocket watch. Now, how do we calibrate that watch, right? Because it's got to measure time accurately. We might go to the internet or get some digital time mapping. Now, how is the internet calibrated? It might be calibrated against some other standard which is based somewhere, and eventually, how are all those standards calibrated? They come to the original tabulation, which is basically the global standard for time measurement, which is the second, where the second, which is the SI base unit, is defined by the precise vibration of cesium 133 atom, a certain number of cycles of it. Now, this is where the problem starts, because the movement of cesium does not actually measure duration, it measures distance or displacement. More accurately, it measures displacement. Now, suppose the entire universe is slowing down and speeding up, and all the particles in the universe are simultaneously slowing down and speeding up, or all the movements are simultaneously slowing down and speeding up in the same proportion. There is no way we will know, right? Because we are not measuring pure duration, we're only measuring displacement. So let's explore this idea a little bit, right? Where we are saying time is a measure of displacement and not of duration, right? And that becomes our first hypothesis. In fact, the hypothesis is basically saying there's no such thing as duration. Let's see how where it leads to. So let's use RC3 to see if we can do a review of this. Let's say case one, there's a universe in which absolutely nothing is moving, right? So everything is perfectly static. There is no way we can measure time. There is no use of measuring time. There is no way we can calculate how long the universe has been static. Nothing. So the concept of time that will not exist and makes no sense even if we try to create it in a static universe. So clearly we need something moving. So let's give it something moving. Let's say this orange particle goes in an absolutely straight line, and it's moving at, we don't even know if it's a constant speed or not, because without a measure of time we can't find out, right? The only way we can measure time in this universe is by looking at the position of the orange particle. That's the only indicator of time. And the only thing we can do with the time we measure in this universe is to figure out where the orange particle is. So it'll sort of be a circular logic saying, if the particle is here, then the particle is here. And we don't really have any use for time in this universe. So clearly, even movement is insufficient. Let's go to case three, where let's say there's a simple harmonic motion, right? An SHM, where the green object keeps going around in a circle. Again, is it a regular movement or not? We cannot really determine, because we'll need time as a separate measurement to look at an SHM. So let's say, but there's an interesting thing here that happens compared to case two, where we can say that the universe has aged by x number of circles of the green object plus some. So, for example, if the green object is on the has completed 17 circles and it's moving 30 degrees on the 18th circle, I can say the universe is 17 circles old. Right? So, a simple harmonic motion does introduce a way by which you can create an age of the universe using movement. Yeah. So clearly, we need more than one object for time to have any meaning. So let's say there are two objects which are moving in the universe. Then we look at the position of the gray object and we tabulate the position of the orange object. That's pretty much what we are doing even in the case of the experiment above, where we have the two trains with A and B. We're looking at the position of the cesium object and saying it's moved this much, and therefore the two trains are moving this much, right? So we kind of get that difference. Yeah? So, since time cannot exist without movement, clearly there's no such thing as duration. So, is time relative rate of change of position of one object with respect to the other? And did simple harmonic motions lead to the hallucinating duration, right? So, basically, is duration a hallucination which has come from SHMs? I'll let you guys think about it and let me know what you think. Yeah. Moving forward, so what are the implications of this thought process, right? So there are already certain indications where this kind of an idea has been present. For example, if you look at the Vedic definition of time, and the Mayan calendar also has something similar, we have a hierarchy of simple harmonic motions. So you've got a muhurta, which is supposed to be about 48 minutes. There are like 8 prayers in a day. A day is the rotation of the earth. Then Paksha is a fortnight, which is a half cycle of the moon, let's say from full moon to no moon or vice versa. Then you've got Masa, which is a month or a month, where a simple harmonic motion of the moon moving around the earth. Then we've got a Samvatsara or a year, which is the earth moving around the sun. Then we have a Mahayuga, which is, let's say, the sun moving around a super sun, and so on. So basically, it looks like these guys have tracked simple harmonic motions at multiple hierarchies, and they've tracked simple harmonic motions which we are not currently aware of, right? So, for example, we don't know what a Manvantara, Kalpa, etc. might represent actually. But Mahayuga, we might find out that there is a super sun around which the sun moves. From a modern perspective, humans have added onto this hierarchy by creating the definition of second, minute, hour, or 60 minutes makes an hour, 60 seconds makes a minute, and then you got the SI levels where you're saying millisecond, decisecond, decasecond, and so on. So you got a complete hierarchy set there. Um, Similarly, there's a very interesting notion which is there, which is this timelessness. For example, Eckhart Tolle talks about the definition of now in his book, The Power of Now. Similarly, there's the story of Markandeya, who moved beyond time to escape death and so on. So there does seem to be a concept of timelessness somewhere in here. So question is, are the Vedas too advanced for us to understand? Because we don't exactly know what their origin is and what the ideas they're posing to us. Basically, the question is, do they know something that we do not? Similarly, has anyone ever measured duration, or is this just a hallucination? Right. So that these are some interesting questions. Also, I'd like to know if there are similar references in the Quran or the Bible, which talk about there being no such thing as duration. From a time perspective. Do let me know if there's anything I'm not. It'll be interesting for us to get aware of it as well. Yeah. So moving forward. This brings us to an interesting question. We have got distance on one hand and displacement on the other hand. So, are there really two different types of length measures? So, let's say that there are 2 points A and B, and we measure the distance between them, and we say that's, let's say, 10 meters. So, let's call it distance meters. Similarly, let's say there's an object which moves from A to B. So, we would say the object has been displaced by 10 meters. So, let's call them displacement meters, right? So are distance meters and displacement meters really different? That's the question we're asking. So let's take Newton's first law, where he says an object at rest or in uniform motion, which means in some way he theorized that there is some similarity between objects at rest and objects moving in uniform motion. Now, maybe a framework like RC3 would have helped him think through that in totality, but that's always conjecture. But it does raise an interesting point, which is that a distance meter could be looked at as a special case of displacement meter, which basically means, let's say I want to measure the distance from A to B. Let me keep everything else in the universe absolutely static. I just take that measuring instrument, take it from A to B, and bring it back to A, so that by the time the instrument has done its movement, there is no change in the universe, and then I allow the whole universe to continue moving. That is the same as zero displacement in time, right? So essentially, if the object goes from A to B and back in no time, which means nothing else in the universe is moving when this is moving, that makes the displacement meter, a distance meter, a special case of displacement meter, which means distance meter is equal to displacement meter is equal to meter. So we just need 1 meter to measure both of them. And that also means that measuring second is the same as measuring meter, because when we are measuring displacement, we are basically measuring distance. So, question for you, space time means there are um, three dimensions of space in which there are objects which are stored, and the time dimension means that the objects are just moving around. Is this basically what space time is, or is it much more complicated, where time is a separate entity which is embedded into space? What are your thoughts on this? Another question then becomes, in the theory of relativity, we measure the contraction of length when we measure the length of an object in another moving reference frame. That leads to the Lorentz contraction. Similarly, when we measure time, we measure time dilation. Are these two therefore basically measures of the same thing, or similar things, because they're basically both measures of distance, or or displacement, however you want to call it? So how are these actually different, or how are these similar? I'll especially leave it to the physicists to figure this one out, because I'm not an expert on relativity theory yet. Moving forward, so what does this mean from a science perspective? It does raise a very big question. So this is the definition of science we started with, where we say, okay, we define the measures, metrics, etc., conduct experiments, and lead to laws of nature. Then the question becomes, what are the kind of metrics we measure? There are seven base metrics, which is meter, mass, time, electric current, etc. And we have a whole bunch of derived metrics which come from, or derived units, which come from the primary units. Um, Based on our discussion, what we are essentially saying is the meter and the time, the two primary metrics, are essentially the same, right? They're just a restructuring of each other. So, does this mean that we have to basically revisit everything we've discovered in science so far, which is based on meter or time, to recalibrate all those theories? And then the other question is, this seems so obvious. So it obviously begs the question, is there something we are missing in our analysis in this video? If so, I'd like to hear it from you as to why this whole video might not actually make any sense. So because something like this missed for the last 2000, 5000 years also does not make sense. A lot of really smart people have worked on this, so there could be something very obvious which you're missing here. Yeah. Would love to hear your thoughts on this. So, in closure, these are the 8 questions that we've asked in the video. Do post your comments, based on what you think. And as of course, as always, if you want to explore any of my courses or want to have any specific discussions with me, my contact is in the slide. Thanks for listening.